All right, let's jump to the third problem. Integral of tan to the power of 5x dx. The way to solve this particular problem is split this tan to the power of 5x into tan cube x into tan square x. And I will rewrite this tan square x in terms of secant square x. And you will know why I'm doing this in a bit. So integral of tan cube x, tan square x can be written as secant square x minus 1. So this is going to be integral tan cube x times secant square x dx minus integral tan cube x dx, right? But we know that the derivative of tan x is secant square x. So I can write secant square x dx as d of tan x. So integral tan cube x d of tan x minus integral tan cube x dx. So again, I will do the same thing. Split this tan cube x in terms of secant square x, tan x into tan square x, right? Tan x into tan square x dx, and do the same thing that I just did. If I simplify this integral tan cube x d of tan x, it is going to be tan to the power of 4x divided by 4. Tan power 4x divided by 4 minus, so tan square x can be written as integral tan x into secant square x minus 1 dx, right? So just distribute it. Tan power 4x by 4 minus integral tan x into secant square x dx, minus into minus plus, so it is going to be plus tan x dx, right? So secant square dx can be written as d of tan x. So write that tan to the power of 4x by 4 minus integral tan x into d of tan x. And integral tan x dx is simply natural log of modulus secant x, right? So this is very simple. It is simply looking like integral x dx, but we have tan x. So it is going to be tan power 4x by 4 minus tan square x by 2 plus natural log of modulus of secant x, and finally our integration constant c. This is going to be our final answer. Tan to the power of 4x by 4 minus tan square x by 2 plus natural log of modulus of secant x plus integration constant c. I like this problem. This is kind of simpler than the previous problems. So let's just review what we just did. So the integrand is integral tan to the power of 5x dx. So I split that tan power 5x as tan cube x into tan square x, because I know that I can write this tan square x in terms of secant square x. So I have rewritten tan square x as secant square x minus 1 and distributed that. So integral tan cube x into secant square x dx minus tan cube x into 1. So integral tan cube x dx. This will give me integral tan cube x. So I can rewrite the secant square x dx as d of tan x. So that will become integral tan cube x d of tan x minus. So now I simply have integral tan cube x. So I will repeat the process. So split this tan cube x into tan x into tan square x and rewrite this tan square x as secant square x minus 1. So the first term is tan to the power of 4x divided by 4 minus integral tan x into secant square x dx. Minus into minus is positive. Integral tan x dx. So we have minus integral tan x d of tan x. So that is tan square x by 2. And integral tan x dx is natural log of modulus of secant x plus integration constant c.